Okay, hey guys. So today we are looking at this task, this relationship of inverse functions to exponentials. So very specifically, we're going to be looking at what the inverse function of an exponential looks like, what the key features of that graph would be. So we're really going to be tying in what we know about inverse functions and what we know about graphing exponential functions. So to save your time and my time, I went ahead, I've already sketched the final graphs here for both of mine. So as we look at them in a little bit more detail, we already have an idea of what they're going to look like. Now, in order to get these graphs, I had to use an XY table. And so we know that whenever we're trying to find points for an XY table, the very first thing we ever want to do is always go ahead and choose our X values. And we can choose any X value. But when you're starting with a graph that you don't know much about, it's always a good idea to start towards the origin. So I typically start around -2, -1, 0, 1, 2. Often I might stop there, but I get an extra box, so let's go ahead and do 3 as well. Now, in order to find these points, I'm going to be using my handy dandy graphing tool. We know that what we're doing is we're just plugging those x values into the function and then simplifying. But that can be a lot of work and a lot of room for error. So in this world of technology, let's have the technology do it for us. So y is equal to 4, parentheses, 1 over 2. We're going to go to the side so we can close that parentheses to the x. Scroll over, so we got back down on the normal level, and then -3. So here we have it. You can go ahead and see a little bit of the picture there above it, which does look like our blue graph when I move this away. Now, to actually get these points, any graphing capability is going to have a table for you. Here, I hit that gear. Now there's this little icon that looks like a table. I click it, and there we go. We have the table itself. So I can now see I have these points. It has most of them for me. So -2 is going to be 13, 5, 1, -1, -2. I'm going to click on this one. When you click on an x value, you can change it. So I'm going to pop in 3 and gives me -2.5. So for the time being, we're going to throw that away because we have our coordinate points. Now we know that the biggest relationship between an original function and its inverse is that we switch those x and y's. So here I have the coordinate points of the blue graph that I have sketched on here. In order to get the coordinate points of the orange graph, I just switch these. So 2, 13 becomes 13, -2. -1, 5 becomes 5, -1, and so on and so forth. And these are the points that I have graphed over here. And do know that I went ahead and fully sketched in my graphs. I put arrows on both sides because these are continuous graphs. This one's going to keep going up. We're going to keep going flat here. So we have all of that. Our graphs keep going. So we went ahead with those arrows there. I also have the line y equals x sketched in. And that is because we know that inverse functions are reflected over this line. We also talked about the fact that if they intersect, they're going to intersect on this line. And so we can see that the point of intersection is on y equals x. Let's be a little bit less than 0.5, 0.5. So this is what we did just the very first day looking at inverses. We just plotted the points, we graphed them, we sketched. But very specifically, here we started with an exponential. And so we need to talk about those key features of the exponential. We know when we're trying to find key features of an exponential, what we really mean is we're talking about the y-intercept, the horizontal asymptote, the domain, and the range. These are what we are looking for. So I can both use my graph, my table, and my equation to find these things. The easiest one is actually going to be the y-intercept. I see it right here when my x is equal to 0. It is 0, 1. I also know that because I don't have an h value, I could have done 0, a plus k, which would have been 0, 4 minus 3, which still gives me 0, 1. So either way, I get that same point. All right, so as we keep looking, the next thing then is asking about the horizontal asymptote. We know that our horizontal asymptote is our k value. sends me y equals -3. We can actually come over here and sketch that in. And we can see that our blue graph is actually approaching this line. So it is in the correct place. We can see that we have this horizontal asymptote on the right-hand side of our graph as we're trying to reach it. So we have that right there at y equals -3. For an exponential, we said that the domain, no matter what, if it's an exponential, is going to be -infinity to infinity. And then the range, because we are not reflected, our a term is positive, our range is just our k value up to infinity. So -3 to infinity. That's once again saying that our y's, our lowest y's we're going to see are right above this horizontal asymptote. And then as we go up, we always have a y value. So we can see we start down here and then we're going to keep going up and we keep seeing our blue graph. And this arrow means that it's going to keep going on forever. So we found the key features here. Now why this is really cool is because we're talking about that inverse relationship. And so because we're talking about that inverse relationship, we know that everything that was dealing with an x value now deals with a y value and vice versa. So because I had a y-intercept, that means I should have an x-intercept now at that same value. So I have an x-intercept of 1, 0. And in fact, we see that on our graph. Now we need to talk about this idea of a horizontal asymptote. Well, horizontal asymptote is y equals -3. So we know that's going to become x equals -3. Using our knowledge of asymptotes and what this looks like, that actually becomes a vertical asymptote. We know that an x equals is a vertical asymptote. So we can try and sketch in that line and see if it does, in fact, we see that on our graph. And as we look at that, we can see, hey, yeah, this orange graph, this inverse one, it is becoming more and more vertical next to this line, x equals -3. So that's really, really cool. If your graph, if your original one had a horizontal asymptote, the inverse ends up having a vertical asymptote. The last thing that we saw then was that we talked about that the domain and range will also switch places. So here, my domain is going to become what my range was, so -3 to infinity, and my range is going to become what my domain was, so -infinity to infinity. If we look at the graph, once again, we're looking at the orange one now. We can check that out. Oops. The domain is saying what x values exist. Well, the orange graph, it doesn't exist over here because there's this vertical asymptote. There isn't actually any orange graph to the left of it. The orange graph only starts to exist on the other side of this vertical asymptote, so on the right-hand side of it. So it starts just on the other side of -3, and it's going to keep going on forever up until infinity. So we can see that domain here starts on the other side of x equals -3, and it keeps going. The range just means that this one, we know this one's going to spike all the way up because it's going to follow that asymptote all the way up. And then over here, it's hard to tell. These graphs, people like to think that this actually tapers off, but really this is going to go ahead and keep going down slowly and slowly, slowly, but it is going to keep going down and down and down. So we will, because the graph keeps going on and we don't have a horizontal asymptote for the orange one, we will actually eventually reach -infinity for the range. So the big thing I want you guys thinking about here is this relationship. What was the y-intercept is now the x-intercept. What was a horizontal asymptote is not a vertical asymptote. What was the domain became the range, and what was the range became the domain. So whatever is the inverse here, the inverse of an exponential, so that's what this is here, an inverse of an exponential, it has a vertical asymptote and a restricted domain. Let's once again just see what that's going to look like for one more example. Same thing here. I was able to use my graphing tools to help me out. So I can write in a new equation here, y equals 2 to the 3, or 2 times 3 to the x. I'm going to scroll over so I'm back on the right level, minus 1. I'm going to hit the gear again and then the table so I get the table up. Here, as I put numbers in, I kind of see that my y values get really high really quickly. So instead, I'm going to start at -3 instead of -2. And let me make sure I have the right color here. I have -3, -0.9. Let's bring that back to -2. Oops, that's -23. That's not what I want. -2 is going to be -0.8. We have a -1 there, -0.3. 0 is 1, 1, 5, and 2, 17. So just using my capabilities here, my graphing capabilities, help me find those points. Same thing that we talked about above. Now that we've done that, I can just use these points to create the points of my inverse one. So we're going to switch each of them. And we have those graphed here. We can kind of zoom in and look at it in a little bit more detail. So this one, the multiplier is a little bit bigger because it's 3, so it is a growth. It scoots up really, really quickly. And we see that in the inverse. We see that same type of relationship. This one is kind of cool. They don't intersect ever. And pretty much what that means is that the original one never has a coordinate where it's the same value. We could write it this way or this way. There is not a coordinate where the x and the y are the same value, so therefore they don't intersect because it doesn't have a single point that lays on the line y equals x. So that's just a fun thing to look at here, but doesn't really mean anything for us. So once again, what we're really talking about here are those key features and seeing how they're related to each other. And so we want to see some of the same stuff that we saw above. So we're going to be talking about the same exact key features. We want to be talking about the y-intercept, that horizontal asymptote, that domain, and that range. So y-intercept, once again, we could do it the long way out, or we could just look at our graph, and we see that we have it at 0, 1 again. That's just a coincidence. Immediately, I'm going to go ahead and say that means that my inverse must have an x-intercept there. That's that relationship of an inverse. And in fact, I see that. That point just flipped. We're good to go. When we look at the horizontal asymptote, we know once again our horizontal asymptote is just that k value. So we're going to say we have a horizontal asymptote at y equals -1. I'm going to sketch that in on my graph so I can see it and see if we do actually see that relationship. So I'm going to come down to y equals -1 and sketch over a horizontal line. I don't even need to do it on the other side because this is the side with my asymptote, and we see that it's leveling out, it's getting flat as it gets closer and closer to that y value of -1. But what we just saw is that if the original one has a horizontal asymptote, then the inverse must have a vertical asymptote at x equals -1. And I want to sketch that in and see if I see that that is true. So I'm going to come over to x equals -1, and I'm going to sketch down. And sure enough, I do see that relationship again. There's this vertical asymptote. It's getting closer and closer to it. And as it gets closer, it becomes pretty much a vertical line, which is what we know is that relationship, the behavior of the graph near an asymptote. So that's the really cool thing here once again. I did not leave myself enough room. So let's see if I can scroll down to talk about domain and range. The domain we know is, always infinity to infinity. So we can say that the range of this inverse one is going to be -infinity to infinity. It's the other one that becomes kind of tricky. So here, the range was from that horizontal asymptote up, so -1 to infinity. So that means the domain of my inverse one is going to be that same thing. I'm starting at -infinity and I'm going to, or sorry, I'm starting at -1 and I'm going to infinity. So we've seen all of these relationships now. the key takeaways that I want you to think about as we move on and as you prepare for class next week is that the inverse of an exponential, and we're actually going to talk about what those are called because it's something new for you guys. But the inverse of an exponential has a vertical asymptote and a restricted domain. That simply means it's not negative infinity to infinity. Versus, if I even want to go over here, I could say that an exponential has a horizontal asymptote and a restricted range. The one last thing that you might be thinking about is we talked about when we first talked about inverses, how to get the equation for this other function. I challenge you to try it, but you're going to hit a roadblock. And so that's what we're going to be talking about next week is what do we do? How do we actually find this equation? What is it called? And now we already know what key features we're going to be looking for. And so we're going to talk about the rules and how to find those when we have an equation. So there you have it. This is kind of our task, our relationship of very specifically looking at what happens when we look at the inverse of an exponential.